So children, standard 12, the part 2 video. Just now I have uploaded your Bayes theorem. So the few important questions. For example, you have a person A, 60% cases A tells the truth. Probability of a person telling the truth is 60%. So probability of speaking the truth. So probability of speaking the truth is 60%, and therefore what is his probability of lying? Not the truth. So we write T bar, not the truth. So chances of lying. So that will be chance of not speaking the truth. That is chances of lying will become chance of lying. So that I am writing as P tilde bar, that is 1 minus 6 by 10, which is 4 by 10, which you can reduce it as 2 by 5, right? So here it is 3 by 5, and chance of lying is 2 by 5. For a statement, there can only be two outcomes, where it's the truth or it's a lie, right? For every statement I make. Therefore, that is why the complement of that is lying, not the truth, is 2 by 5. Now, this person, I speak truth in 60% cases, and therefore I lie in 40% cases. So if I throw a die, okay, if I throw a die and I say that it is a 6, okay, if I throw a die and I say it's a 6, what are chances actually a 6? So what is the meaning of actually a 6? When I am saying a 6, okay, either I am telling the truth or either I am telling the lie. So it is Bayes theorem, because you have, I am saying it is a 6, that's a common event. In one case I am telling the truth, and one case I am telling a lie. So therefore, chances of me, okay, chances of, it's actually a 6. So A stands for actually a 6. That means I am speaking the truth. So there are two events, true and lie. In truth also I say a 6. In lying also I say it's a 6. So when I throw a dice, I say it is a 6. So what are chances? It is actually a 6. Meaning he is telling the truth. So probability that it is actually a 6. So you can say S for 6. And he's speaking the truth is probability of his speaking the truth, and probability that is a 6 speaking truth. So I'm just writing this notation, should see explaining it. S stands for 6. So the common thing here is saying it is a 6. Saying it is a 6, you're lying or you're saying the truth. So now it is actually a 6 means you're speaking the truth. That means really the 6 has fallen. So probability is a 6 and you're speaking the truth is probability of speaking the truth and saying. And what will be the denominator? The total probability of falling of a 6, whether it's a true statement or it's a false statement. So probability, same thing you repeat, and it's a 6 and you're speaking the truth, plus probability you're lying, and it's a 6 and you're lying. Okay, so therefore speaking the truth, I said 3 by 5, and it is a 6. What are chances? When you throw a dice, it is a 6, 1 by 6. And here I repeated 3 by 5, 1 by 6. And you are lying. Lying means it is not a 6, but you are saying it is a 6. So lying probability is 2 by 5, and it is not a 6. So not a 6 is 5 by 6. So you can cut out the 6's, right? And therefore it is 3 by 5. And you have a 3 by 5, and you have the 5 also gets cut, plus 2. And then you add it up, or you can say 10 by 5, so that you have 10 by 5, so 3 by 13. Okay, so here this is a little difficult to understand, that you are saying it is a 6 in two cases. You're lying or you're speaking the truth. Now the question is, it is actually a 6. And not actually a 6 will be, naturally you write this on the numerator. Okay, it is actually a 6. That means it is a truth statement and falling of a 6. So true statements, falling of a 6. I repeat that. Plus you're telling it, you're lying. So what is the chance of lying? 2 by 5. Okay? That it is not a 6. You're lying, saying it is a 6. So 2 by 5 into 5 by 6. Okay? This is one which you cannot clearly, it's not as clear as when you read it, you're confused whether to do Bayes theorem or what other way should I solve this probability sum. So the next example is a letter comes from Kolkata. There are two a letter is addressed. Okay, there's a letter addressed, one from Kolkata and one from Tata Nagar. I am from Tata Nagar, the Tata Steel made by J.R.D. Tata. So Tata Nagar, many of you don't know, it's a small town that's also called Jamshedpur, and I'm from there, right? So there are two letters, one from Kolkata. Let us take the new spelling of Kolkata. Okay, Kolkata, and the other one comes from Tata Nagar. Due to rain, all the letters are wiped out in the address and only TA is left, TA. So what are the chances that the letter came from Tata Nagar? Okay, you got a letter and TA is rubbed out. All the letters are rubbed out due to rainwater, and only TA is left. So what are the chances the letter has come from Tata Nagar? Okay, if you take Kolkata, am I right spelling? Suppose Kolkata. Okay, and old spelling also will do. Suppose given this in the sum, that this spelling of the old spelling of Calcutta and Kolkata. So this is Kolkata and the other letter is Tata Nagar. Now this is a little difficult to do. So letters come from the letters addressed to two places, that's Tata Nagar and Kolkata. Okay, and due to rain, all the letters are wiped out. Only TA is left. Only one TA is left. So you get this, and what are the chances that this letter came from Tata Nagar? So you don't know because only TA is left. So there's a doubt whether it's come from Kolkata or whether it's come from Tata Nagar. Okay. So here, what are two letters coming to you? So what are chances of the letters coming from Kolkata or either from Kolkata or Tata Nagar? So the chances of coming from Kolkata is half. The chances of letter coming from Tata Nagar is half. T for Tata Nagar I'm writing, K for Kolkata. Okay. So chances of the letter coming to me, 2, 1 out of 2. So that's first event. Second one, both the places have TA in it. That's the common event. So because both are, the TA is in both, it is a confusion that the letter has come from Kolkata or it has come from Tata Nagar. Okay. Now this is a little difficult. You are going to pair the numbers. Okay. Only two neighboring letters are left. So in Kolkata set, you have, I have the pairing of numbers. CO, then OL, then LK, then KA, then AT, and then TA. Why I am pairing it? Because two consecutive numbers. Now I will not pair T, K and K because they don't come next to next. So just the numbers, the one left to the letter and one right to the letter. So we are forming pairs. So Kolkata, KO, OL, LK, KA, AT, TA. How many? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. What did I miss? KO, OL, LK, KA, AT and TA. So how many are there? This KO, OL, LK, okay, LK, KA, AT, TA. So how many pairs of neighboring alphabets? 1, 2, 3, 4, 5, 6. Yes or no? So what is the probability that TA is from Kolkata? Probability of TA AT was not left in the letter. TA was left in the letter. So 1 out of 6. 1, 2, 3, 4, 5, 6. From the 6 pairs, so AT coming of TA in Kolkata is 1 out of 6. Okay, the TA coming from this. So the common event, the TA, this event, suppose I say it is the common event E. So what is that TA? That means the common event to come from Kolkata is 1 by 6. Am I right? Little difficult, isn't it? Now coming to next one, now to find the probability of TA from Tata Nagar. And Tata Nagar has more chances, the letter to come from Tata Nagar, because Tata Nagar has is very special. My place, Jamshedpur, is a special town. It's a beautiful township. It is also called Jamshedpur. So Tata Nagar has two Tatas, Ta and Ta, right? So let's say, now I'll have it for Tata Nagar. So Tata Nagar, now for the second set we are saying Tata Nagar. So the thing is TA, AT, TA, AN, NA, AG, GA, AR. So I'm just pairing two consecutive alphabets, one next to the other, because the rain TA is left, that is why. It's not that one T from here and one from A. Okay, the Tata's TA is left. The rainwater has rubbed that way. So we are seeing now the probability of the common event from Tata Nagar. How many Tatas are there? Two Tatas are there, right? And how many pairs? 1, 2, 3, 4, 5, 6, 7, 8. So 2 out of 8, which I can write as 1 by 4. Okay? 1, 2, 3, 4, 5, 6, 7, 8. Let us write again. Let us see. TA, TA1, 2, 3, 4, 5, 6, 7, 8. Alright? So 8 pairs. So 1 by 4, and there are 2 Tatas. Now the rainwater has wiped out all the letters except the two consecutive alphabets TA of Tata Nagar or TA of Kolkata. So what are chances the letter has come from Tata Nagar? Okay. So therefore probability of the common event to happen from, okay, you have Tata Nagar, okay, from the word Tata Nagar is probability of Tata Nagar into probability of the TA from Tata Nagar. Yes, and repeat this, half into 1/4, and now Kolkata, and Kolkata is probability of the letter from Kolkata is half, and probability the TA has come from Kolkata, we wrote how much? 1 out of 6. So now here again half is common, so gets cut. So 1/4, and you have 1/4 plus this, okay, that is 3 plus 2, 5 by 12. So that is 1/4 into 12 divided by 5, 3 by 5. So probability, I told you, probability of TA from Tata Nagar, okay, is 3 by 5. Probability from Kolkata, it will be 2 by 5. Okay, 1 minus 3 by 5, that is 2 by 5. Right? So naturally if it's Kolkata, it will be this 1, 2, 3, 4, 5, 6, 7. Okay. So 1 out of 7 it becomes if you take the old spelling of Calcutta. Right? So then only here instead of 1 by 6 it will be 1 by 7. Whatever the spelling is given accordingly. This is one kind of Bayes theorem which are a little difficult to do in the Bayes theorem. Suppose you have another example before I wind up. Suppose you have trucks. Okay, there are 300 trucks plying on the a given street. Okay, in a given time. In a given time, say let us take 1 straight mile road or whatever it is. I have 300 trucks plying in that road, and then I have 1200 two-wheelers. Okay, and then I have suppose 500 cars. Okay, chances of, then you have accidents. Chances of accidents Okay, by trucks is 5%. Now you can also, in decimal also it can be given as 0.05. Chances of accidents by cars is 2%, say 0.02. And chances by two-wheelers is say 4%, 0.04 or 4%, whatever. Now, an accident takes place on this street. So, what are chances this accident has taken place by a car? Okay. So, generally we say, oh, truckwala rash, they drink and they drive and it must be a truckwala. No, everything chances doesn't mean it can, you can surely say it is happened by this. No. Okay. Then it won't be a probability. So, on the same street where 300 trucks ply and 1200 two-wheelers and 500 cars, on the same street an accident has taken place, because the common thing for all these vehicles is accidents. All accidents are caused by any of these three. That is common event, right? So, there is an accident on the same street. What are chances this accident has occurred by a car? Okay. So, therefore, that will be, so first I will do chances of the probability of trucks. How many trucks? How many trucks? 300 trucks. Out of how many? 15 plus 5. Out of how many vehicles? 2000 vehicles. So that becomes 3 by 20. So probability that it is a truck is 3 by 20. Now here it's not equally likely events, children. Probability that it is a two-wheeler, I'm writing W, I'm explaining so you can see it, and that is 1200 out of 2000. So that out of 2000. So that becomes 12 by 20, 4 3s are 4 5s. And it is a car, probability of car. How many cars? 500 cars out of 2000. So that becomes 1 by 4. So this is a probability of the three situations, that is 3 cars, the trucks and the cars and the two-wheelers. What is the common thing which all of them can happen with any of them? That is the accidents. And there's an accident and nobody has seen what has collided into that person or what caused the accident. Nobody has seen it. So then what are chances, not seeing, nobody has witnessed it, that this accident has occurred due to a car. Okay. So therefore, now I know, knowing this, now Bayes theorem, right? So you have probability that the, let's say accident, the common event, accident. Probability, we call it as A. So accident has occurred by a car is probability of the car and probability of the accident by a car divided by, repeat this, car and accident with a car, then probability is a truck into a probability accident by truck plus probability it's what is that, two-wheeler and probability accident with a two-wheeler, right? That's all. And then you put the respective numbers. What are they? So accidents, you know, trucks is 0.5% and cars is 2% and what was two-wheelers is 4%. So therefore, I write it down. Oh, I forgot. What is this? How many trucks was that? Okay, 1200 and you have 500. Right, cars. So you write the respective numbers. We had how many? We had trucks 1500 and we had cars, no, trucks was 300, sorry. Trucks was 300 and then you had cars was two-wheelers was 1500 and cars was 500. Okay. Doesn't matter if I have messed up with the numbers. What is the probability? It's a truck. Yeah. So cars were, number of trucks were 300, number of two-wheelers was 1500 and cars was 500. So I asked you what is the probability. So probability of car is here 500 by 2, sorry, 500 by, I had 2000, right? So what was that? 12, 17, okay, let it be like this. 1200, 300 and 500. So probability it is a car is 500 by 17, 2000. So I had 1 by 4, okay. Probability it is a truck, so I write it on top. Say, so probability it is a truck. The trucks are how many? 300 and total vehicles are 2000. So that is 3 by 20. Then probability it is a car. That car, how many cars? 500 cars out of 2000. That becomes 1 by 4. And probability it's a two-wheeler. That's 1200 by 2000. And that is 3 by 5. Okay. So knowing this, now put the values. Now what is it? What are chances the accident has occurred by a car? So that is probability of a car. What was this? 1/4. So here I write. So the Bayes theorem that the accident has occurred by a car. Probability of the car is 1/4. Am I right? Here 1/4. And accident by car is 2%. 2 by 100. So repeat this, 1/4, 2%, then probability is a truck, 3 by 20, and accident by trucks, 5%, and probability it is a two-wheeler, that is 3 by 5, 1200 by 2000, and accident by two-wheeler, 4%. And solve the sum as it is, half 100 gets cut, you can cut the 100, right? Here it is half in the numerator. So you have half in the numerator and then solve the sum and you get the answers. Half divided by half plus 5 fours are. So 3/4 and here you have 12 by 5 and solve the sum as it is. Is it clear? So these were some of the sums which I just discussed, and if it helps you, it'll be fortunate for you and me. So thank you, children. If you have any queries or you want me to just give some more sums, then please message me, like, share and subscribe. Okay. Thank you, and my next video will be on probability distribution. Okay. Thank you, children. All the best and do well.